Last class, we discussed about the what is mapper and reducer driver class, and how we can write the mapper class, reducer class, and driver class. How to run the MapReduce program, uh, and then I explained the how many mappers will get if you submit the job. How many mappers will get? uh, how many reducers will get, how to increase the reducers, and what is the failed job, how we can kill the running job. So these are the things we saw practically. So I think I hope you got idea about the all these mappers and reducers, and also failure job, and how we can see the uh, errors, and also how we can see the counters statistics of the job, how many map records are there, how many mapper input records are there, output records. Same way, reducer input records and reducer output records. So on yesterday we practiced the word count program. Similar, we have the few more program. So we'll practice those things, and we'll also discuss two concepts of there, combiner and partitioner. We'll discuss those things also. Okay. Before going to that, yesterday uh, we executed the same word count programs by single reducer and multiple reducers. So if we are getting any errors, how it failed. So these all the things we saw. So yesterday I think I forgot to show the if we are having the multiple reducers, how the output will be there. So this is the output. So if we are, yesterday I think we executed one job with them three reducers. So if we executed with multiple reducer, for each reducers we will get the separate file. So with 000 01 02, like this we will get the separate files for the each reducer. So for each reducer output is the each output reducer output will be sorted by the keys. And how the mapper output will what mapper will limit the intermediate results. So which keys will go to the which reducers, that will be who will manage that one means we'll have one concept called partitioner. So I will tell later. Once we practice the example, then we'll go through the partitioner. And this is how we'll get the output from the different reducers. Okay. Okay, then we'll go through the word occurrence problem. This is one more example, word co-occurrence problem. Like yesterday, this one word count program. Same, we have the one more example we are going to see. This one we'll see one example here clearly. So word co-occurrence, like word count, it will be word co-occurrence also similarly like that only it will be there. In this, what we are going to do means count the number of times word appears next to the each other. So yesterday we count the number of words in the file. So now we are going to count the number of times these adjacent words, how many times it is repeated. So these things we are going to find. For that, what we'll do means, instead of taking the single word, we are going to adjacent words we are taking, and we are trying to count. So like this, first we will take these two, next we will take these two. Like this, we will take the words, and finally how the output will come means this is the will come 3 times. Is a is occurred in 2 times. So if you observe here, so this the adjacent word 2 times, 3 times. Similarly, is a 2 times. PDF only 1 time. Hadoop, these things. A Hadoop is the 1 time. This one is 1 time. So like this. So like this we are going to find. So this is one more example. So here we are going to use same logic. Little bit difference only will be there. Instead of taking the single word, we will take the 2 words. Okay, then we'll similar like word count. We can import the word co-occurrence program. I think only difference it will be there in mapper. So everything same. Extending the mapper is same, and these input keys and values also input and output key values are same. Everything is same. So here what we are doing means similar like word count program. We will get the line and we will split by the words. Here what we are doing means we are getting the current word and next word. So index I and index I plus 1 we are getting, and we are merging with the colon. So here key, what is the key means combination of first word and next word. So like this we are forming the key. Previous previous word count example, we are forming the key only a single word. Here we are forming the key with the multiple words. So here key will be the current word and next word, combination of those two, and the count will be same. Here we will return the 1. So except this everything is same. Reducer what we will do means similar like word count program. So we will we will sum the all the list of values for the single key. Similar keys we will get the list of values. So we will iterate the all the values and we will sum the all the values. So finally we are key and the final sum we will emit from the reducer. We will create the jar and we will. I'm going to already jar is there. I'm going to create one more jar. I'll go through that part. Home. So just we will change the jar name and we will change the driver name. I think package is same package. So we'll run it. Same like yesterday, we will run it. So so here we have only small file, so that's why only we got only one mapper, and reducer we by default will be there one. So here we execute on this input. So for this input, we have only one block, so it is less than 64 MB, so we'll get only one block. So the output we can see in word co-occur output. So here the output, if you check it, so like this we'll get. I think most of the things here we check it, we'll have the maybe first word will be space, so that's why we got empty previously. So if you observe here, so here we'll get like this, first word space colon undue, like this we'll get the output. So similar adjacent word we'll get like this. So this is one more example. I think similar like yesterday word count program, but only difference is the adjacent words. This inverted index program where we will use means mostly this kind of we can use in this search engines. Actually, 1 minute I will explain. Actually, where we'll use this inverted index means, so now if I have the lot of words, lot of files. So in that files, if I pick the one word, suppose if I pick the this word where it is occurred means suppose if I want to search for any this word, what are the files this word is there. So if we want to find like this, we want to do the inverted index. Okay. Actually, inverted index where we'll use means, suppose if you in search engines, if you search any word, so suppose if we search for the some Hadoop, bottom if you click on search button, we'll get the lot of files. So where it is repeated, so those file information will display. So for that one, basically in search engines daily they will receive the lot of files. So while searching itself, if they want to search this word in all the files and returning the result means it will be very it will take lot of time. So that's why internally what they will do means they will already map the files. So which word will be repeated in the which words. they will maintain the some index. So this index will call it as a inverted index. So how they will maintain, suppose if you have the 10 files, so in that 10 files, which word is repeated, which word is exist in the what are the files, so that index they will maintain. So like this, suppose if you take one word, so where it is in what are the files, it is what are the files contains this word, so that information they will maintain. So this thing we'll call it as a inverted index. So finally, how the we will get the output means like this, we'll get hi, and what are the files this word is repeated. So like this we'll get how, and what are the files it is repeated. Like this will maintain the index. So this kind of index when it will be useful means, if you want to, if you have the bulk some thousands or millions of files. So if you want to, while before going to search, if you want to maintain some index kind of thing, if you run the MapReduce program, we can easily uh, find the mapping, this index we can maintain the easily. So we'll see the how the program will be there. So this is the basic uh, idea about the how the inverted index will be there. Just we will write the simple logic, similar kind of things. What is the what, and what are the files it is repeated, we will see. So here we will get the word, we will get similarly same way, we get the each word, and this word, what are the files it is repeated, we will maintain the forgetting the name. Suppose I'm going to run the program on the Shakespeare. So here I have the 5 files. So these 5 files, so particular word, suppose the word, the word, what are the files it is exist. So for finding that one, suppose if I am processing the comedies files, so I need to get the file name of comedies. How we can get that name, we will see. So we will get by using the file split. File split. Before that one, we need to context dot get input split. We will get the file split. So from that file split, we'll get the, if you call the get path, then we'll get the file name. So this file name we can set. We can emit as a value. Keyword is the normal word, whatever the we are getting the words, so each iterator will get as a word. File will be the each input split, we will have the same name, so that name we are returning. So previously if you observe here, so we are returning the text and interwritable count we are returning. Now we are returning the both text comma text. So that means, so here we are returning the keyword as a text. Keyword we will get the word, and value we are returning as a this also text. So this is also name, file name. So that's why both are the text. So reducer side, what we'll do means simply instead of previous examples, we we are iterating and we are summing the adding the values. So here what we are doing the mean, yes, simply we are appending with the comma. So whatever the I think for each word we'll get the list of file names. So those file names here we are appending with the comma. By using comma we are appending. So finally we will from reducer what we will get means we will get the keyword and we will get the list of file names we will get. So everything then driver will have the same mapper setting reducer, and here we'll change the instead of text and iterable we'll change to text and text. What are the values we are returning from the mapper and reducer? Same we need to define in the driver class. So remaining all the things same. So in previous example we are returning the keyword and count. Here we are returning the keyword and file name. So in reducer we will get the keyword and the list of file names with comma separated we will get. We will run it and we will see how the output will be there. We'll go to that path and just I'm changing the driver name and jar name we need to change. And input path and output path I will change. So here I'm giving this Shakespeare. So in this we have the 5 files. So we'll check it how the output will be there. So for this, we got the 5 mapper tasks. So why we got 5 mapper tasks? We have the 5 files. We have the 5 files. So that's why each file will be in separate block. So that's why we got the 5 mapper tasks. So if these are the small files also, so we will get the different files. It is stored into, each file will be stored in different block. So that's why here we have the each file have the one block. So here we have the 5 different blocks. So that's why uh, we got the 5 mapper tasks. So here we got the 5 mapper tasks. Reducer is the same, one reducer only. We having one reducer only and 5 mappers. So here we can check how many, similar like yesterday, we can check the how many mapper input records, mapper output records, and reducer input records, reducer output records. We can check it, reducer output records. So here we will check it. So like this we will get. If you check here, so some names are there in the only some files, poems. Some words are there in the some files only. Here if you check, this word is repeated in the, I think, 4 files. Tragedies, histories, comedies, and glossary. So like this, so we can maintain the each word is repeated in the which file. So like this we can maintain the inverted index. So this is one more example how we can use the MapReduce program. Okay, this is one more example, average word length. So this is similar like word count and the word co-occurrence. So here what we'll do means, here we'll take the how many average length will start with the initial letter of the word. So here this is the one example. So here if you check it, so the word is start with T is only one word is there. So average length is the only 4 letters. So we have one word. Then the length is, average length is 4. Like this we have the one next word is started with high. So there is no words with started with high. So we have only one word with 2 letters. So average length is 2. Like this A also only one word. So 1. Then if you this is 2. These 2 words is starting with H. So this having 6 letters. This having 5 letters. Total we have the 11 letters. By how many words? 2 words. So 11 by 2 means 5.5. Like this is simple example how we can do different ways how we can do MapReduce program. This is one more example like average word length. So next word is only one word is there, then 2 letters, then exercise 9 letters. So like this we'll find the average length of the each word. So like this finally we'll get the some words we will output for the this program is single letter space and the average word length. Like this we'll get. Okay, I will show the program. Then you can practice simply how I'm loading the file. Same way you can load the file, load the project, and you can try to execute yourself. Import. Next. Here we will have average word length. So here we will get the character, first character of the each word. Then we will get the length of the word. So here we'll have the small calculation. I think for getting the character and length of the word. Length of the word, I think we'll get same. I think how many, suppose we have the Hadoop, so we'll get the 5 letters, 6 letters. So like that, we will return the each character and word of the length of the word we will return in mapper class. Reducer class, we will do average. So we first will find the sum, then we will find the how many words is there count. So like this we will do the sum by count, then we will get the average length. So we will return the key comma average word length we will return. So this is one more example, average word length. You can try to run it. So if you are facing any problems, I will help you. So these are the different examples. So next classes, I will actually till now we are handling with the text data. Next to I think we need to discuss some topic. So after that, I will try to explain how we can load Excel file, how we can read the Excel, and how we can process with the MapReduce Excel files, how we can read and how we can process with MapReduce. Next classes we'll see. This is till now we saw only text related data. So next classes I will explain the Excel kind of data. So once we have the some other concepts, so I think customizing the input format and uh, uh, customizing the writables. So after discussing that one, we'll go through how we can read the Excel files and how we can uh, uh, read the Excel file and how we can form the output. So through MapReduce, how we can process the Excel files. Will show one example. Similar way we can do it for the Word files or any other files. We can do it. Okay, these are the some examples of the MapReduce program. How for basic understanding of the how we can write the MapReduce program, how we can run it, and how we will get the mappers and reducers. So these are the examples. So basically, we will have the main in MapReduce. We'll have the one main phases are the mapper and reducer. Basically, we'll have the mapper and reducer. In that middle, we will have the sorting. Sorting I already explained. So based on the by default, based on the key, so each reducer output will be sorted by the key. So framework will take care of the sorting internally. Internally, there will be some sorting algorithm. So next one more phase is shuffling. For shuffling, uh, uh, what is shuffling phase, what will do means mapper output will pass to the reducer input. That process will that phase will call it as a shuffling. So it will take the mapper output and it will pass to the reducer output. So this middle of the mapper and reducer, we will have the called shuffling. In shuffling, in partitioning also will be there in shuffling process. So which mapper output we need to pass to the which reducer, that will also will be there in the shuffling. So in shuffling we'll have the sorting, copying the mapper output to the reducer input, and also we'll do the some merging. So uh, uh, forming the reducer input like this keyword and the list of values. So this thing also will happen in the shuffling phase. So shuffling, it will be in the middle of the uh, mapper and the reducer. It will receive the mapper output, and it will uh, pass to the reducer input. So in that one, uh, we'll perform some operation, sorting, partitioning, and shuffling the values. So all this will happen in the middle of the mapper and reducer. So these are the two other phases, sorting and shuffling. Shuffling, we won't do anything. Framework will take care of the shuffling process. For sorting, by default, it will sort by the keys. So if you want to customize, if you want to do the other sortings also, we can do. I think we have the one more main sorting is secondary sorting. So next classes, I will tell the what is secondary sorting. These are the main phases: mapper, reducer, sorting, and shuffling. Uh, in MapReduce program, we have the main, these are the main phases: mapper and reducer, sorting and shuffling. Then we will see the, we have the some other concept, combiner, partitioning or custom partitioning, and tool runner. Today we will see, we'll discuss about these things. Tomorrow we'll go through other concepts, secondary sorting and custom writable and custom input format. So, okay, first we'll come to this one, combiner. So what is this combiner? So yesterday we saw while running the this word count program. So mapper emitted the lot of keys, and it needs to be copied to the wherever the reducer machines are there. It needs to be passed through network, and it needs to be copied to the reducers. Then reducer will perform the aggregation operation. Finally, it will emit the results like this. So, but what is this combiner? Combiner, we will call it as a local reducer, and mainly it will use for the improving the performance. So combiner run at the local node. They combine the results of the all the map tasks before sending map outputs to the reducer. So here what we'll do means, this is the one mission. This is the one mission. So finally, previously we don't have this combiner. Whatever the results will come, we will pass to the reducer. So in combiner, what we'll do means, what are the operations we will perform in the reducer, same operations will perform in the each mission. So here what we'll do means, suppose in one mission we are multiple mappers are running. So we will take the all the output from the mappers. Whatever the operations we are performing the reducers, same operations will perform on the each node. So then we can reduce the intermediate results, we can reduce by using this combiner. So if you observe here, we have here in this first node, we have the three mappers. So from these things we will get the mapper will emit the output like this, key and list of values, key and list of values like this will emit. So previously directly these intermediate results directly we are passing here, but here what we are doing means, in combiner what we'll do means, whatever the similar words is there, so we are combining, and we are passing to reducer like this. So previously, instead of passing red 2, we are passing the red space 1, red space 1 2 times. Here green 1, green 1, green 1 3 times we will pass. So intermediate results will have the lot of data. So for reducing the intermediate of data and for improving the performance, we will use the combiners on the each machine. So reducer what we'll do means, finally we will aggregate the different mappers output. So same thing what we are doing means, instead of doing globally, so first we will do it in the each machine. So then we will reduce the intermediate results. Whatever the data we will pass through network from mapper to reducer. So that data we will reduce. We will we will decrease the size of the intermediate data, and we will pass to the reducer. Final reducer what will do means, for each machine it will receive the input data, and all the machines data it will be uh, aggregate globally. So finally we'll get the word and count like this we'll get. So this is about the combiner. So previously directly we'll get the map and list of key comma value to, and directly reducer like this we don't have the combiner phase. So combiner what will do means, same what are the things we'll do in reducer, same things we'll do in the combiner. So but combiner will be in the each machine. J. I have a question from J. I think so. Combiner wants like a reducer, but at the SS. It is in the each node level. So from each machine it will be execute. Yes. Yes, J. Correct. So mainly why we will use combiner means, we will use for the improving the this one for improving the performance we will use. So we will see example, then you will get more idea. Same basic word count, we will see how we can implement the combiner. So here if you observe previous word count or other examples, we didn't use the combiner. So that's why we are getting combiner output records are 0. Similar like combiner inputs should be there, combiner input records also 0. Now we will try to add that combiner and we will run it, then we will get the difference. I think yesterday I think for running the this one word count program, it's taken I think 9 to 10 minutes, and lot of words are returning from the this one mapper, and reduce also we are getting reducer input, we are passing lot of records. So if you use the combiner, so we can reduce the performance, but now we are using only 2 missions. So if we use the more missions, then we can achieve the more performance. But we will see how maybe in 2 node mission also, whether we can improve the little bit performance or not, we can check it. I think if we are having the more nodes, then we will get the more performance improvement. So everything mapper and reducer same. Suppose if we want to implement the same reducer, whatever the things we need to write in the reducer, same things we need to implement in the combiner. Simply what we need to do means, here instead of mapper and reducer, same like mapper and reducer, we need to add one more line, job dot set combiner, and we will set the same whatever the reducer class is there, we will add same class. So mostly whatever the operations we want to we will do in reducer, same thing we will do in the combiner class. So no need to write the separate class, and whatever the simply we will set the combiner reducer class as a combiner. So if you want to implement other different logic rather than reducer logic, so then you need to write separate classes. So that classes also will extend the reducer. So how we can implement the reducer? Same like we can implement the one more reducer class. So that reducer class we will specify Here we will specify. So now we are going to perform whatever the similar operations we will perform, and we will check it. So same program, I change input path and output path, and I set the number of reducers equal to 3. We will run it. We will go through basic outcome. I think jar name is different. Okay, we will run it and we'll check. So while running the job, you can check the status here also, or we can check the job, how much percentage is completed. So here if we check it, so previously we didn't get the combiner input records and combiner output records. So like mapper input records and mapper, till now we are running only mapper. So mapper input records, mapper output records, and also combiner input records. But maybe here we are using only two nodes. That's why I think maybe if you use combiner also, we'll get only little bit performance. But if you use the more nodes, so in that cases, I think we will have the more performance by using the combiner. So we'll check how much performance we'll get here. I think if you observe here, so combiner input records are we getting, I think 54 million. So here combiner output records are only 997,000. So basically, so all these generally input records are this one and output records are this one. But if we didn't use the combiner, so whatever we are getting as input records, all these things, all the combiner records, we need to pass through network for the reducer machines. Suppose if you have the 10 node cluster, so whatever the mapper input output records we are getting, So all the output key value pairs we need to copy to the reducer. In that cases, we'll have the lot of data. So if we have the similar keys from each machine, if we are returning the lot of similar keys from the each machine, so if we use the combiner, so we will get the input records will be convert as a we will combine internally and it will return the less key value pairs. So it will return. So here it is taking 108 millions and it is returning only 2 millions. So like this we can increase the data, how much data we can pass, we can pass through network, we can decrease. So here if you observe, I think almost completed, I think, yes, completed. So same whatever the basic word count program we executed yesterday. So data also same and mapper and reducers also same and everything is same. So yesterday it takes I think nearly 9 minutes. So if you check here, today I think 3 minutes 38 seconds. Same two node cluster and everything is same. Everything is same. Two node cluster and we reducers are same. 3 reducers and the number of mappers and everything is same. What we did means instead of simply using mapper and reducer, we implemented the combiner. So if you use the combiner, we'll have the lot of performance improvement. I think if you check here, yesterday it takes I think while using single reducer it takes 10 minutes, while we are using 3 reducers it takes I think 8 minutes. I think now if you use the combiner it takes only 3 minutes 38 seconds. So we can improve a lot of performance by using this combiners. When we can improve combine performance means, suppose if you have the similar keys multiple times, we have the similar keys we are returning from the mapper output, then we will have the lot of performance improve by using the combiner. So I think this is all about the combiner, how we can write the combiner and how we can check the combiner input and output. We can check here how many records are there from the combiner input and output records. We are getting a lot of output records and a lot of input records are there. If you check the previous examples, yesterday and previous example, we didn't use any combiner, so that's why we have the 0 records for the combiner input records and output records. Why we'll use this partitioner? Partition performance, partition based on keys and intermediate map. So we have the different mappers. Mapper will emit the intermediate results or mapper output. So this mapper output, suppose if we have the multiple reducers, 2 or 3 reducers, which mapper output, uh, uh, which output, which mapper output needs to go to the which reducers, it will be decided by the partitioner. So partitioner by default will have the partitioner, framework will have the partitioner. So partitioner what will do means, internally it will use some hash functions. Based on the hash codes, it will be separate the mapper output and it will separate the mapper outputs and it will pass to the particular reducer. So by default it will use the some hash functions. By using internally it will use the some hash codes. Based on that one it will separate the mapper output and it will pass to the particular reducer. So if you want we can customize the partitioner. So for that we need to extend the partitioner class. I will show that code also. So main thing partitioner means it will mapper process of sending the specific key value pair to the specific reducer is called the partitioner. So what are the key values we are returning from the mapper? So uh, for uh, for sending to particular specific reducer is called a partitioner. So total number of partitions is same as the number of reducer tasks for the MR job. So how many partitions, number of partitions equal to number of reducers. How many, suppose if you are having the 3 reducers, you will get the 3 partitions. So that is about this MapReduce partitioner. So I will show how we can implement the custom partitioner. By default, we will have the framework will have the partitioner. We no need to implement the partitioner. I think if you observe previous example, so we use the 3 reducer. So 3 reducers, each reducer will have the some output data output. So how it is partition, how it is how the which mapper output will pass to which reducer, who will take it. Default will framework, MapReduce framework will have the default partitioner uh, partitioner. So it will take care of the that passing the which data will needs to the pass to the reducer. It will take over the it will take care by the partitioner. If we want, we can customize the partition. We can customize the partitioner. That concept we will call it as a custom partitioner. So we will check how we can write the how we can customize the part. You can import the project. We have the project. Using partitioner. So same mapper, reducer, driver class. Driver class is same. We need to implement the partitioner class. So if we want to implement custom partitioner, we need to extend the partitioner class. This partition class also will be MapReduce API. So we need to implement one method called get partitioner. Here we will write the logic for the how we need to split the data. So from how we can split the mapper output data to the reducers, how we can separate the data. We'll write the logic in the partitioner thing. I will tell one example. Suppose if I have the suppose if I have the 10 years data. So if I want to pass the particular suppose 2000, I have the data from the 2001 to 2010. So 2001 year data I need to pass to the first reducer. 2002 data I need to pass to the second reducer. So in that cases we can implement the our custom partitioner, and we can implement the logic for the passing this particular year data to the particular reducer. We can implement like this. So same way here we are implementing the custom partitioner. Here how we are doing means here we will have the 2 reducers. For first reducers, if the letter, if particular word will start with these words A, E, I, O, U, we will pass to the first reducer. Otherwise, if any particular word, if it is start with the other letters S, T, other letters, then we will pass to the second reducer. So here based on this partition number, so it will pass to the particular reducers. So how will like this. So if we are having the more reducer, we can implement we can partition number, we can give the 0, 1, 2. Suppose if we are having the 2 reducers, we will assign the 0 reducer. If you observe the reducer output files also, it will start from 0 index. So that's why we are passing the partition number 0 and partition number 1. So it will, whatever the assigning the partition number 0, it will pass to the reducer 0, and it will whatever the partition number 1 will pass to the second reducer. It will pass. So like this, only if you implement the logic in this get partitioner, and if you submit this partitioner class to the framework, framework will take care about the splitting the data. So only what we need to do means we need to override this get partitioner method, and we need to implement the logic. So then framework will take care about the separating the data. So this is the basic idea about the partitioner. So after implementing the class, we need to specify this partitioner here. We need to specify the job dot set partitioner class, and whatever the partitioner class is there, we need to set here. So whatever the things, if you want to improve the performance and if you want to implement some other concept, we need to specify in the driver class. Suppose if it is the combiner class, we need to specify in the driver, and partitioner, if you are going to implement partitioner, we need to specify in the driver class. So this is the how we can write the custom partitioner and how we can implement the custom partitioner. Tomorrow we will execute and we will see how the data will be partitioned, how it will be passed to the different reducer. Tomorrow we will run it and we will check it. So this is the about the combiner and partitioner. Tomorrow we'll see how we can run the partitioner, and we can go through the some other concepts, how the secondary sort will be the custom writable and custom input format, and we'll see the other concepts in the MapReduce. Okay, thank you all. Tomorrow we'll continue the class.